Hi, so in this video we're going to be covering similar triangles, which is the main topic that we covered in week 6 of our math class. Now in order to tell if two triangles are similar, either of three conditions must be met. And we're going to look at each of those conditions and try some examples on the way. The first condition that tells us if two triangles are similar is if three angles are the same for both triangles. Here we have two triangles, triangle ABC on the left and triangle XYZ on the right. If we look at triangle ABC, we can see that one of the interior angles, or the angles inside, is 72 degrees and another angle is 35 degrees. But we have one missing angle inside the triangle, right here. In order to find this angle, recall that the angles inside a triangle always add up to 180 degrees. So if we want to find this angle, we can simply subtract the given angles from 180 degrees. So here I'm going to do 180 minus 72 minus 35 degrees, which is give us 73 degrees. So I'm going to write 73 degrees here. Now let's take a look at the triangle XYZ on the right. Again, we have 72 degrees inside this triangle and 35 degrees. To find the missing angle, we can do the same. We can apply the same rule. 180 minus 72 minus 35, and we get the same answer of 73 degrees. Here we can see that all angles are the same for both triangles. So we can say, based on the rule or the condition, that triangle ABC is similar to triangle XYZ. And the reason is because all three angles are the same. We use an abbreviation of A, which tells us that the reason these two triangles are similar is because all three angles are the same. That's why A stands for angle, angle, angle. Now the second condition that tells us if two triangles are similar is if their corresponding sides are proportional. And what does that mean? Well, what it really means is that each pair of sides for the two triangles have the same ratio or fraction. But how do we know what each pair of sides are? Well, let's try to look at it as an example. So let's look at the triangle on the left. This one right here, triangle ABC. We're going to match each side of triangle ABC with the sides of triangle XYZ on the right, this guy. First, I can see that the smallest side on triangle ABC is 4. Now if we look at the other triangle, what is the smallest side? We can see that the smallest side is 5. Now it only makes sense that the smallest side on one triangle matches or corresponds to the smallest side on the other triangle, if they were similar. So I'm going to match 4 and 5. Now let's take a look at another side. What about 6? This is the next smallest side on triangle ABC. On the other triangle, the next smallest side is 7.5. So I'm going to match these two sides. And finally, we can match the remaining side, which is 8 for triangle ABC and 10 for triangle XYZ. Okay, so now half of the work is done because we've matched the sides for the two triangles. But we want to know if the corresponding sides are proportional. What does that mean? Well, we want to form the ratio for these pair of sides. So remember, 4 is matched with 5. So I'm going to write a fraction, 4 over 5. That's one pair of sides. Let's do the second pair. 6 over 7.5. And the last pair, 8 over 10. Now, the next thing we want to do is simplify all of these fractions so that we can easily tell if they are actually the same. Can 4 over 5 be simplified any further? No, right? Okay. Can 6 over 7.5 be simplified any further? If we divide the numerator by 1.5 and the denominator by 1.5, we get 4 over 5. Great. What about the last fraction? Well, if we divide 8, the numerator, by 2, and the denominator by 2, we get 4 over 5. And here we can see that all fractions are the same. And if we recall, the condition was that if the corresponding sides are proportional, meaning all fractions are the same, then these two triangles are similar. So then we can say the triangle ABC is similar to triangle XYZ, and the reason is because all sides are proportional. We write the abbreviation SSS, which stands for side, side, side. Now the last condition that tells us if two triangles are similar is if two pairs of corresponding sides are proportional and their included angles are equal. First of all, you may be wondering what an included angle is. Well, an included angle is just an angle that is in between two side lengths. So if we take a look at the first triangle, for example, over here, we have a side length of 15 and 21. And in between those two sides, we have an angle of 75 degrees. That is what we call the included angle. Okay, now let's try to prove this condition for the two triangles shown here. First, we can tell already that the angles, or the included angles for both triangles, are 75 degrees. So right off the bat, we can say that the included angle is the same for both triangles. Okay, but that's not the only part of this condition that we have to prove. We also want to check if the two pair or the two pairs of corresponding sides are proportional, kind of like what we did for the second condition. Okay, so if you remember, one thing we want to do is match the sides to the corresponding sides on the other triangle. So let's take a look at the triangle on the left, triangle ABC. We can tell that the smaller side is 15, and on the other triangle, triangle XYZ, the smaller side is 10. So it only makes sense that these two sides correspond to each other. And the larger side is 21. So on the other triangle, 14 would be the corresponding side. Now we can write our fractions like we did in the second condition. So we can write 15 over 10, and we can write 21 over 14. Now, can we simplify these two fractions? Well, if we divide the numerator by 5 and the denominator by 5, we get 3 over 2. For the second fraction, if we divide the numerator by 7 and the denominator by 7, we also get 3 over 2. So, both fractions are the same. Therefore, we can say that the two pairs of corresponding sides are proportional. Now we can say that triangle ABC is similar to triangle XYZ. And what's the reason? Well, the abbreviation is side, angle, side. Remember, for this condition, we have two sides that are proportional, and the included angles are the same. That's why the abbreviation is side, angle, side. So now let's take a look at some of the examples from your homework. This is question 2 from your assigned homework, and here we're asked to fill in some blanks. We're given two triangles in a little bit of a weird orientation, but it shouldn't be a problem as long as we follow the conditions that we've talked about earlier. So, the first blank that we have to fill in is part A over here, and it wants us to say if triangle ABC is similar to the other triangle and for what condition. Okay, so the first thing that we can notice is that for triangle ABC, we are given two sides and an included angle. And the same applies to the other triangle. We have two sides and an included angle. So maybe we can check the third condition that we looked at earlier, right? Two pairs of corresponding sides are proportional and their included angles are equal. Maybe we can check that for this question. Okay, so let's try to do that. The first thing we can see is that the angle over here is 60 degrees, and the angle, or the included angle, for the other triangle is also 60 degrees. So right off the bat, we can say that the included angles are the same. Okay. Now let's take a look at the sides. We want to know if each pair of sides are proportional. And how do we find the pairs? Well, on the triangle on the left, triangle ABC, the smaller side is 2 centimeters. So on the other triangle, the smaller side of the ones that we looked at earlier is 3 centimeters. So that means that the other pair must be 3 centimeters and 4.5 centimeters. Now let's write our fractions. 2 over 3 and 3 over 4.5. Now let's try to simplify these fractions and check if they are the same. Can 2 over 3 be simplified any further? No, so let's just leave it at that. Can 3 over 4.5 be simplified any further? Well, maybe we can divide the top or the numerator by 1.5 and the denominator by 1.5 to give us 2 over 3. Now we can say that the fractions are the same. Therefore, the corresponding sides are proportional. If you recall, the third condition that we looked at, 2 pairs of corresponding sides are proportional and their included angles are equal, which is the same thing that we can see here. 2 pairs of corresponding sides are proportional and the included angles are equal. So to fill out the blank in part A, we can say the triangle ABC is equal or similar, to triangle APQ. Now, if you're wondering why I ordered the triangle name as APQ instead of another letter, like for example QPA or PAQ, well, we know that the first triangle is named ABC, so we're going from A to B to C. So for the second triangle, we follow based on the corresponding sides. Remember, 2 corresponds to 3, so we're going to go from A to P to Q. Okay, that's good. Now, what's the reason or the condition that was met? Remember, 2 corresponding sides are proportional and the included angles are equal, which is this condition, and the abbreviation is SAS. So for this question, we can write SAS. Okay, now let's try part B. Now part B is asking us to identify the value of angle B. In the drawing above, angle B is right here. Okay, so how do we find angle B? Well, we're only given one angle in this triangle, but on the other triangle, we're given 2 angles. We're given 60 degrees and 41 degrees. We're also missing another angle in this triangle, but if you remember, it shouldn't be too hard to find this angle because we know that the angles inside a triangle always add up to 180 degrees. So if we do, and I'm going to put that here on the top, 180 degrees minus 60 degrees minus 41 degrees, this should give us 79 degrees. So I'm going to write that over here, 79 degrees. Okay, that's good. Now we just have to figure out which angle on this triangle corresponds to angle B on this triangle. So we know that one angle is 79 degrees and the other angle is 41 degrees in the triangle on the right. But we have to find the angle on the triangle on the left, or angle B. One way we can tell is by looking at the corresponding sides for the triangles. Remember that this guy right here, 2 centimeters, matches or corresponds to this guy, 3 centimeters. Well, the closest angle to 3 centimeters is 79 degrees. So, on the other triangle, that angle, angle B, must also be 79 degrees. Therefore, the other angle will be 41 degrees. So to answer the question, we can write that angle B is 79 degrees. Okay, so now let's do the second part of filling the blanks. Here it's asking us to write fractions for the similar triangles, or a ratio. We have BC in the numerator, and then blank in the denominator is equal to blank over blank. Okay, so how do we figure this out? Well, we're already given BC, which is just the line segment from point B over here, point B to point C, right? There. To write the fraction, we have to write the corresponding side on the other triangle in the denominator. Well, the corresponding side on the other triangle is from Q to P, right? And the length of Q to P is 3.9 centimeters. So we can write 3.9 centimeters. Now what about the other side of this equation? So BC over 3.9 centimeters is equal to blank over blank. Well, one thing we can do is choose a side or a pair of sides that we already know. We know one pair of sides, which is 2 centimeters and 3 centimeters. So we can write 2 over 3. Now we just have to find the value of BC. And how do we do that? Well, we can use this equation right here. You can treat BC as a variable and isolate for that variable. If you recall, when we did algebra in our first week of class, we can isolate for BC, and I'm going to do that here on the bottom. BC over 3.9 is equal to 2 over 3. Now we're going to say BC is equal to 3.9 times 2 over 3. BC is equal to 2.6. So we can write BC is equal to 2.6 centimeters.